Okay, this is a lesson on radicals. We're going to learn all about them, and you might be saying to yourself, what's a radical? Okay, well, the radical that you're most accustomed to is the square root. That's the most common one that you already know about. There are actually a whole bunch of other ones, but the square root is a radical. The actual thing that it's set under is called a radical. We'll talk more about that next time. Well, how do you get to roots and square roots? We've talked about this before, but let's mention again how it works. Well, where do squares and square roots come from? Why do we call it a square root? I mean, really, what is square about that? Well, let's think for a moment, and maybe we'll come up to it. Okay. Well, you know, square roots, that's all about multiplying and like unmultiplying, right? Well, one way to think about multiplying is to think about length and width. What if they happen to be the same thing? So if you've got length times width, and say if the length is n and the width is n, then that means it's going to be n times n, and it's going to be a shape. A shape that looks like that. Oh my goodness, what's the name of that shape? Oh yes, it is the square. Okay, so what I did here is I took n, and the other n, and I squarified them. I made n into a square by multiplying. So then I have n squared. Oh my goodness, who'd have thunk it? That's why we call it that. Oh wait, so n squarified makes n squared. Yeah, okay. Well, don't I remember there being another special one for like the 3 or something? Yes, there is. So if we have length times width times depth, length, width, depth. So we're thinking in 3 dimensions here. See what happens when I get this? So if the length is n, and the width is n, and the depth is n, then how do I find the volume? Now since it's 3 dimensions, it's volume. N times n times n. And n times n times n is n cubed. Into the third power. N cubed. Into the third power. Oh, look! It's n made into a cube. There you see it. Imagine it there. Yeah, it's cubified. I have cubified n. N times n times n. And oh, you know what? When I multiply n times n, the lazy school of mathematics, says I'm tired of writing n's. I just want to put this number here. It says I wrote it 3 times. So I wrote it 3 times and I multiplied. But notice, in real life, a really good way to model multiplying a number times itself again is a cube. Okay? So this is a cube because that's what happens. Okay? You multiply n times n times n, and you're doing it in real space and in real with a figure, you're going to get a cube. That's why n cubed gets the special name. Can you say n to the 3rd power? Why, yes, may, yes, sir, yes, ma'am, you may, but we usually say n cubed. N squared is n times n. It's n squarified. N cubed is n times n times n. It's n cubified. So we shorten it. We say n squared and we say n cubed. Now you may be saying to yourself, well, that's all well and good. Those are kind of fun special names. I wonder if there's any other special names. For example, I understand that if I multiply n times n times n times n, that'll be n to the 4th. Well, let's see. Given these examples, I drew a 2-dimensional shape, length times width, that's n times n, and I could look at it and see it and touch it. And I can see it's n squared. Then I did a three-dimensional shape, n times n times n, and I can make it. It can be something that I actually have, and I can pick it up and throw it at my friends or whatever. It's a real thing. 3 dimensions, 2 dimensions. Okay, well, if we're doing this here, this would be like 4 dimensions. Really? Earth to class, wherever you are, out in cyberspace, there's no 4 dimensions. We live in a 3-dimensional world. Yes, we do. And some people say, well, like time is the 4th dimension or something is the 4th dimension. Well, you know, really, if you can't pick it up and throw it at the frog, don't throw anything at me. No. Okay, frog, I won't. Thank you. If you can't pick it up, like I can pick up the frog, and actually do it with it in 3 dimensions, then, well, we don't have a nickname for it. It's not that n to the 4th is not a perfectly good number, a perfectly good construct, but what it is we don't use it in real life. These we use in real life like all the time. Okay? People who are drawing things or building things will use squared and cubed all the time. It's very common. It's used. Things that are common and get used get nicknames. These have nicknames, squared and cubed. This one is not something that you use when you're building a building, at least not very often. It's not very common, so it didn't get a nickname. And that's true for all of the other powers. It's only the 2 and the 3 that gets the nickname. All the others don't. Okay, so when we write a square root, it'll be with the square. Right now I'm just talking square root. It'll be with the square root sign. We'll put the number inside, and if we want to multiply it by something, we won't set it over here just because I get sloppy, and I don't know where my thing is. So when we're multiplying by a number, we'll put it first. Say if that's 2, then we'd write it. This is just good grammar for algebra. You don't have to do this, but this is just how we usually see it, and that's how you'll usually see it. So I really prefer that you do it that way. Okay? So let's think about square root functions and what they look like. X is the input like it always is in a function, at least in our system. So this would then be the square root of x, and that's going to be y. It could also be f of x, depending upon how you want to write it. Remember that f of x is another way to write the range. Okay, so y is going to be the range, also f of x. And x is going to be the domain, just like you're used to already. So this one, right